So now we're going to talk about some example problems from section 4.1. Okay, finding coterminal angles. So in this case, determine two coterminal angles in radian measure, one positive and one negative for each angle. So there are many correct answers. So this is 7 pi over 8. So the easiest way to do this is to take our negative 7 pi over 8, which is an angle, right? And add 2 pi and hope that ends up with a positive answer. And then take negative 7 pi over 8 and subtract 2 pi. The idea is this means we're going around the circle clockwise, counterclockwise once it gets a new angle. And here we're doing the same thing. We're going we're going clockwise, right? It gets us another angle with a negative measure. The hardest part about this is you must convert this into eighths. How many eighths are there in 2? Well, there's 8 eighths, so 16 eighths. Negative 7 plus 16 would be 9 pi over 8. That is a positive answer. That would be one coterminal angle that is positive. Same idea, except we're going to subtract 2 pi, as in once around. Now, if this was degrees, we'd add or subtract 360. Easy, right? Negative 7 minus 16 pi would be negative 23 pi over 8. And there's our two answers. Determining quadrants. Okay, 87.9 degrees. We assume that this is standard position, so we're going to go this way, 87.9, which is not quite 90. This is in quadrant 1. Okay? Negative 8.5. Also assume standard position, but we're rotating negative, that is clockwise. So this is in quadrant, let's see, this is 1, 2, 3. This is in quadrant 4. Finding coterminal angles. Hey, these are degrees. So, one positive, one negative. So for 445, what we're going to do is find another one that is positive. Now, I happen to know that 445 is larger than 360. Go figure, right? So if I were to subtract 360, that would give me another positive angle that would be equivalent, which is 85 degrees, right? Now, that is our positive. If I want one that's negative, could I keep going? Could I subtract another 360? Sure, I'm just going around twice now. And that's guaranteed to be negative, so it'd be negative 275. So with degrees, instead of the 2 pi, as we had with radians, it ends up being 360 degrees. Now, negative 740. I want to get something that's positive. So what happens if I added 360? That wouldn't get us there, but it would get us another angle, wouldn't it? In fact, negative 740, get this out of here, 740 negative plus 360 is, hey, is negative 380 a possible answer? Sure. Could we take the negative 380 and add another 360 and still end up with a negative answer? Well, you got a couple possibilities for the negative, right? What if I wanted to keep going? Could I? Yes, they want a positive, so I kind of have to. So the key here is to add or subtract 360 until we get a positive or a negative, right? Converting from degrees to radians. So to convert from degrees to radians, I need to get degrees to cancel out and replace it with radians, which means I'm going to multiply by pi over 180, okay? So technically, this is 315 pi over 180 because the degrees cancel out radians. Is this a reducible fraction? Well, what goes evenly into 315 and 180? Oh, I don't know. Let's try 15. So what is 315 divided by 15? It is 21. What is 180 divided by 15? It is 12. So it turns out the reduced form would be that. Okay? Same idea. Multiply by pi over 180. So we know this is going to be 120 pi over 180. The zeros, we get 12 pi over 18. 6 goes evenly into both of these, so we get 2 pi over 3 radians. That's it. Convert from radians to degrees. Do not use a calculator. Okay, so instead of multiplying by pi over 180, I'm going to multiply by 180 over pi. That way the radians will cancel out and I'll be left with degrees. So notice the pi's cancel out, and so I get 15 times 180 over 6, but it is negative, right? Degrees. So it's, now the reason I left this is 180 over 6 is I happen to know 6 goes into 180 evenly. In fact, 30 times, right? So is this the same as saying 15 times 30? Yes. Is that the same as saying 150 times 3? Why, yes it is, which is 450 degrees. Same idea here. You multiply by 180 over pi. Cross-canceling is your friend. Pi and pi go away. 180 and 15. Remember that from the last problem? That means this becomes a 12 and this becomes a 1. So we get 28 times 12. What is 28 times 12? I don't know. 12 times 28, oop, I'm cheating, is 336 degrees. And that's it. Okay, convert the angle measured from degrees to radians, round your answer to 3 decimal places. So we're trying to get rid of degrees, which means 180 is going to go on the bottom, 180 degrees, so the units cancel out, and then pi radians. Now this is where it gets a little bit tricky. I'm going to treat this pi as right around 3.14159, which means I'm going to take negative 46.52 and multiply it. So 46.52 times 3.14159, then divided by 180. And that will give me negative 0.811 radians. So the key thing here is we treat the pi as right around 3.14159, right? 3.14. Negative 0.57 radians, which means now the pi goes on the bottom and the 180 degrees on top. Same idea. It's going to be negative 0.57 times 180 divided by 3.14159, because we're going to treat that as numeric equivalent, roughly, right? So 0.57 times divided by times 180 is 32.658 degrees. Okay, pretty precise. Complementary and supplementary. Remember, complementary comes first. That is sums to 90 degrees. Supplementary sums to 180 degrees. Now, you'll have to remember that 180 degrees is pi radians, and this is pi over 2 radians. Now, 3 pi over 4. So if you want to find the supplementary, you need to take pi over 2. Oh, so this is complementary, right? You take pi over 2 minus the angle, which is, well, that's 2 pi over 4. Minus 3 pi over 4, which is negative pi over 4. What happens if you get a negative? It means there is no complementary angle. None in this case. So if you want to find the supplementary, you take pi minus 3 pi over 4, which is, well, that's 4 pi over 4. Remember, common denominator minus 3 pi over 4. So the supplementary angle would be 4 pi over 4. So then we repeat this process. Complementary would be pi over 2 minus 12 pi over 5. Ooh, that's ugly. That means I need to put this over 10, which means I have to multiply this by 5, so 5 pi. And I have to multiply this by 2 minus 24 pi, which is a negative 19 pi over 10. So there is no complementary, none. No complementary angle. Supplementary, pi minus 12 pi over 5. Common denominator would be what? So it would be 5 pi over 5. Hopefully you're seeing, because I'm about to get a negative 7 pi over 5 as an answer. There is no supplement. No supplement, no complement in this particular case. Does that happen? Yes. All right, finding the central angle. We have arc length S, radius R. They want it radians. We know S equals theta R. We know S is 10 feet. We know theta is, we don't know, but we know this is 22 feet. So what's the central angle? Theta equals, well, we divide both sides by 22, 10 over 22 radians. Let's just leave it at that, right? Done. Easy, right? Okay. Find the length of the arc on a circle intercepted by that. So S equals theta R. What's theta? Pi over 3 radians times 9 feet is s. 9 over 3 is 3, so this is 3 pi. If you really want to have a number, right, then it'd be 3 times pi, or 3 times 3.14, which is right around what? 3 times 3.14 is 9.42 feet. That's it. So finding the radius. And find the radius of the circle. So once again, arc length equals theta r. Fill in what you know. 3 equals 4 pi over 3 times r. Multiply by the reciprocal, right? 3 over 4 pi. That'll cancel. 3 over 4 pi. So this is 9 over 4 pi is the radius. Now, they're probably fishing for something. Now, it's going to be in meters, right? What is 9 divided by 4 pi? Well, that is what? 9 divided by 4 divided by pi is right around 0.716 meters. Okay? And that, I believe, is that.